Okay, so yeah, in section 2.5, we're going to be using sine and cosine ratios to calculate the lengths. So what are we given here? We're given here an angle and the hypotenuse. So this is the hypotenuse, that's the angle. What's this side here? Opposite. Okay. Now, which trig ratio am I going to use? And it asks me to find the length of PQ. So where's PQ? PQ is from here down to here. So I need to find the opposite side. All right. So which trig ratio is this? Sine. So how do we write out our equation? Sine, and let's call it angle R, is equal to opposite, which is PQ, over hypotenuse, which is RP. So now I've got the letters in there, right? Now next I'm going to write in the words or the numbers. So sine of 67 degrees is equal to, now which is the one I don't know? I don't know this, so I'm going to leave that as PQ, and I'm going to divide it by 10.4. All right, so what's the algebra to solve for PQ? What do I do? Isolate PQ, so I'm going to take this number and I'm going to multiply it here and here, right? So I go 10.4, that cancels with that, so I have to multiply it on this side, and then I'm going to multiply this. So it's got PQ equals 10.4 times sine of 67 degrees. All right, now I just have to find my calculator. That's the tricky part. Oh, there it is. Okay. Make sure you're in what kind of mode on your calculator? Make sure you are in degree mode, okay? Make sure you're in degree mode, so you've got 10.4 times, and then sine of 67. All right, so we get 9.5732. So PQ is equal to 9.5732. So your statement is going to be PQ is approximately 9.6 centimeters. Now nearest, why did I round it to one decimal place? Because it says 1/10 of a centimeter. All right. Next question. It says determine the length of JK to the nearest 1/10 of a centimeter. So first let's find where JK is. JK is from this letter J, and I draw a straight line to K. So it's this one right here. That's what I'm trying to find. Okay, I'm given an angle right here. What is this side called? And then what is this side called? That's the hypotenuse. How do I know it's the hypotenuse, folks? It's the longest side. What else? It's opposite to this 90-degree angle, okay? Okay, so which trig ratio am I going to choose here? So opposite and hypotenuse. So again, this is going to be sine. So sine of angle K is equal to opposite over hypotenuse. Now my opposite is MJ, and my hypotenuse is called KJ. So let's put in the numbers now. Sine of 65 degrees is equal to, does MJ have a number? Yeah, MJ is 7.6. Okay, and then what is the other line? It's KJ? Okay, does it have a number? No. Okay, so what I need to do here is I need to solve for line segment KJ. all right? So how am I going to do that? What do I need to do to this? I need to, since kj is being divided, it's 7.6 divided by kj. I need to bring kj up, right? So in order to do that, I'm going to multiply kj on both sides. So here, I'll do it in a different color just so let's let's make sure this pen works. Kj and then kj. What happens to this kj and this kj? They reduce to 1, so they cancel out. And now kj isn't all, it's up, which is great. It's in the numerator position, but there's still something happening here. What do I do with this? Divide both sides by sine 65. Remember, keep that together. That is one thing together. That is one number. And divide this side by sine of 65 degrees. All right, so now what happens here on this side is these two reduce to 1. They cancel. So kj is equal to 7.6 over sine of 65 degrees. Now, just remember when you're putting this into your calculator, proper brackets and just kind of the sequence that you're typing in your buttons. So 7.6 divided by, and then I'm going to put whatever's in the bottom in brackets. So 65, and then I'm going to close this first bracket belongs with this one, and then I'm going to finish that one off. Okay, so I end up getting 8.3856, and so on. So we can write kj is equal to 8.38567 ... So this line is approximately kj is, now notice here I keep writing kj, and what does the question say? jk? Does that matter? Why not? What is line jk as opposed to kj? This is line jk if I start here and end here. And if I start here, this is line kj. So I start here and I go to there. It's the same line segment, right? Okay, so glad you get that. So this is going to be, how many decimal places do I need to round this to? Nearest 10th. So that means 1 decimal place, 8.4 centimeters long. All right. Okay. I go on to the next one? All right. So let's have a look at this equation, this question here. So we need to draw the picture that is associated to this situation. Let's first read the situation a couple of times to make sure we know what we're looking for. And if I want to know what the question's asking, which sentence am I going to find it in? The last sentence. So let's see, it's asking for how far is the plane. So that means I'm going to be looking for a length or a distance. So it's saying, from a radar station, the angle of elevation of an approaching airplane is 32.5. Okay, so I've got an airplane here. Okay, this is me trying to draw an airplane, which doesn't always, I've been practicing. Okay, I haven't been practicing that well. That's my plane. Good enough? Okay. Now, what is this plane doing? It is approaching what? The ground, maybe? Hopefully? Yeah? Okay. All right. Hopefully it's going to reach the landing strip, right? That's what we're crossing our fingers. The plane will actually get to. It won't get into any buildings or anyone standing there. Now, what is here? What is it approaching? It's approaching airplane. Now, horizontal distance between the plane and the radar station. So I'm going to draw a line horizontally, which is the horizontal distance, okay? And it's saying that this is going to be 32.5. That's the angle of elevation if I go up, okay? Horizontal distance is 35.6 kilometers. How far is the plane from the radar station to the nearest? So right here, this is where I need my radar station. So let's say this is that's the radar station. Okay. And this is where my 90-degree angle would be. So which line are we looking for? So when it's saying how far is the plane to the radar station is here, and the plane is here. So which line are we looking for? Yeah, so we're looking for this line right here. All right. So this is the required distance. Find the two things that they're talking about, and then join those dots. Okay, they're talking about the radar station and the plane. Join those two dots. That's the line we're looking for. Sometimes it's kind of hard to figure out what they're actually asking. Okay, so which trig ratio are we going to need if this is the opposite, right? This is the adjacent, and this is the hypotenuse. So which ones do we care about? Hypotenuse and adjacent? This one and this one? Okay, so which trig ratio is it? Cosine 32.5 degrees is equal to, what is it? Adjacent over hypotenuse? So what's adjacent? 35.6 over hypotenuse, which I don't know. So now I need to solve for my hypotenuse. What is that? So my hypotenuse is equal to 35.6 over cosine of 32.5 degrees. Are you okay with me kind of skipping a step to write that down? Okay. So let's get in here. 32.5 divided by cosine of 32.5. Wait, I typed in one of the numbers wrong. 35.6. Does that look better? Yeah? Okay, here we go. I get 42.2 for the hypotenuse. 2105. And then let's finish it off with a sentence. So the sentence will be, the plane is, oh here, it'd be good if you could see it, approximately 42.2 kilometers, rounded it to the nearest tenth of a kilometer, and make sure you have your units from the radar station. All right. So that's it there. The homework is right here. And if you have any questions, make sure you ask them. And I just want to end off this lesson with saying you now have the tools to solve for any angle or any side of a right angled triangle. So just make sure you use this power with great care, okay? It's a lot of knowledge you've got right now, so we're going to start applying this to other types of situations.